Okay, so welcome everybody. To simplify, my name is Pedro Cardoso, and I'm the Text Analytics Director at Synthesio, which means basically I'm responsible for all that is related to natural language processing at the company. So I'm going to talk about the parallel processing using Python and Gearman, simply because everything we do regarding NLP is done in Python, and we needed to distribute it for other people to use the services. Very brief explanation of what's going to happen. So I'll start by explaining a little bit the needs, so what we wanted to do, what we had in our hands. I'll go through a few possibilities just to very briefly show what exists otherwise than Gearman, which is a job queue system. And I'll finally use Gearman with the Python, so like a small example of how do you put the whole thing together. I'm not trying to make something like important production style, but it's just something simple to do. So starting with the needs, first of all, so what is Synthesio? We are a social listening tool that we also do collaboration and engagement, but in short, it means that we collect through crawlers everything that is happening on the social media, be it Facebook, Twitter, obviously everybody knows, but also all the blogs, all the forums. We go to newspaper also, so the more traditional media. We go through pages of people, like a lot of companies nowadays have their own blogs, and all the comments that are made on these blogs also. We do our data coverage, is basically we get millions of verbatim per day, and so that everybody can understand what is a verbatim, so that will be mentioning it over and over. For us, a verbatim is a document. It's the piece of information, usually text, but it can be like a very short one, like a Twitter, or it can be a very long one, like a blog post. We do coverage on 220 countries with around 80 languages. And I'm going to focus mostly on the data text analytics, so classification, visualization, and this is what we are aiming to. So to understand a little bit more what we tried to do. So we have a dashboard, which is basically the product. So it's a dashboard that will put in a concise way all the information that was collected regarding you. So our customers are a big brand, and they want to know what people say about them in the public media. They want to know if a new product, people say very good things, if they say terrible stuff. If it's, for example, imagine you just release a new car and you want to know if people like the design, if people don't like the design, if they like the technical specs, if they say it's too expensive, whatever. So what we want to do is, first of all, we want to gather all this data. We are going to classify the data, and we're going also to visualize it. So we have two simple examples. The first one, the sentiment per topic. So here you can already see, for example, we start by doing sentiment analysis on the messengers by telling, okay, is it positive, is it negative, people say good or bad things. We can also classify by topics. Are they talking about the specificities of a product? Are they talking about the price? Are they talking about a specific problem? And we can basically, in a concise way, show this to the customer. We can also understand more, do some kind of word clouds with more information attached, so you can see more or less if these words are used in a positive context, so Prius was basically positive, Tuang was, people didn't like it probably. So this is what we want to achieve. We want to process this million of verbatims that arrive every day, and just so that you have an idea, we have close to between 20 and 40 million per day, depends on the day, widely. Usually weekends are lower. And we want to analyze all of this data, and we want to put it in a visible way for our problems. So that we are all understand what's going on here, I am not talking about how the models were created. I'm specifying how we use them in deployment, so how we deployed it. And if you are interested, actually can all talk about later on, but basically we do everything in Python. It's mostly sklearn with some other tools available. There's an LTK, but we don't really use that one. So what we need for our processing. First of all, a new verbatim arrives, so we need to process right away. First thing is to detect the language. Was this written in German, in English, in Spanish, in Japanese, whatever. Once we have that, we are going to do something which is basically the same for everybody, so sentiment analysis. And sentiment analysis, again, the positive, negative. Finally, we'll store it and index it so that it can be used in the tool, but this is not related here. So now we have a new customer, and he comes and he wants to have like his new dashboard. He wants to understand what people say about them. So he will have its own configuration, and this becomes more particular for a customer because a dashboard can be on auto industry, can be on health products, perfumes, it can be on food products like is my cat food killing my cat, for example. And now we are going to do like noise filtering. So like we are going to, first of all, he will do this by setting up kind of search queries. And the first thing is like there will always be a lot of noise. If you can think of, for example, Orange, it's a brand, it's a telecom in the UK and in France, but it's also the fruit. So that can create a lot of noise. So we can do some machine learning to remove all these non-pertinent messages. And then we do topic classification for also. So say, okay, are they talking about which particular set of features of the product or whatever? So this is what we need to do. And again, we need to do it for a lot of data. And it's not one simple source of data. So we have all these processes that are demanding to have this data classified. Finally, also we do like the request from visualization. So these ones we get it into the product, and in real time we need to visualize it. So we need to grab the accumulated data that you want to see after filtered, and we are going to visualize it. So we need to somehow process. We say basically what's the correlation between the words. So say, okay, these words are mostly used in some context. It means something here. So that basically the customer can navigate the data in a more efficient way. So as I was mentioning, we have our crawlings and collections, which are basically a set of lots of programs running. All of them want to ask for the classification. We have our feeders adding data to the dashboards. They also want to classify data. And this is our objective. So what we want to do is up here, these services. Again, so this is like parallel, but I mean, this is just to remember everybody. I mean, doing NLP in general, it's embarrassingly parallel, meaning we have a lot of data to process, but each one is processed independently. We don't care for what's the combination. It's not like we are creating a model that has a lot of data. We need to have like multiple processes accessing shared memory. No, it's simple as that. I mean, each one is by himself. You have a lot of requests. Each request will be processed one by one, and you get the results. But there's one specific point, which is our processes cannot be spawned like easily because we need to load a lot of data. So when you think of a classifier object, you need to load the models, you need to load dictionaries, and whatever else is required for the system. And this can, sometimes it can reach like half a giga easily. So it's not something that you just load from a hard drive and you do a classification of a few sets and you go down and you start again the new sets. So, possibilities. I mean, this is like what we could have done otherwise, but we didn't. Like we could just go and do ourselves our multi-process classes. We could just do a RPC or a job queues. And so starting with the multi-process class, I mean, the basic one is, just create a pool object. You say like, okay, I have like 10 processes running in parallel to process my data as it comes. And you created very simple code. I mean, it's just simple code that anybody can do it in a few seconds, a few minutes. By basically you create a pool, you send the data asynchronously by the pool. You wait until it's ready. When it's ready, you get the results. Or you can basically, if a map basically does like have a list, you will process the whole list one by one, and you get the results of everything once all is done. So the first top is asynchronously, the lower part is synchronous. But of course, I mean, first of all, there's no persistent data. So if you do it just like that, you're going to have to load half a gig every time you have one data to load. So if you have like, like a message, a verbentine of 1 kilobit, and you need to load half a giga. Also, it's single machine as it is, and I mean, it's not really a service. I mean, to do a service, you need to do a lot more. And the objective was not to do something from the ground. Of course, I mean, if you said there's no persistent data in the process, you can actually somehow make it. You can initialize in the pool, you can initialize each process, and you define a global class where you put like your classifier, and afterwards in the actual met function that we'll be calling with the pool, you have this already loaded. So this is like a global will have always available object. So somehow you can do it. But of course, and if you want to do this, you are not going to do it like everything from the ground. You can just use a parallel Python. You can use joblib. There are a lot of possibilities, and those already allow you to like spawn among several machines. But again, I mean, this is not what I want to do. This is very useful when you're actually creating your model. And personally, I use quite a lot the pools just to gather the data. So I have a lot of data together. I collect all the data. I need to process somehow. Everything is like parallel, so it's simple to do, but not the objective here. Another idea is remote procedure call, or RPC. It's just so that I have an idea how many people know of this. Can you raise your arm? Okay, I would say like 20%. So, I mean, remote procedure call is something like you have your object in a machine, and you want to expose its methods to everybody, to anybody. So you create a wrapper around your class, around your object, and through a service, it will basically connect. So any other process can create a proxy object that will emulate all the methods from this other object, which is somewhere in the different machine or in a different process, and you can call it as if it was local. So you just ask for the method, it will connect to through the proxy to the service and returns you the results. There are protocol buffers and thrift, which are from Google and Facebook, if I'm not mistaken, and they are nice. I mean, basically you actually need to define the API. I mean, it's not automatic. Things don't just show up. It's for multi-programming languages and so on. So it's more like it's just a protocol, but you still need to build a lot of things. We have also Pyro 4, and this one I've used quite a lot. It's basically out of the box, so it will understand the methods. It will basically expose them right away. It works quite okay. But again, this is not what we wanted to do, because we wanted to have something more, not flexible, that's the keyword. Like, we want something more flexible that we don't want to mix around with like name servers, because if you want to connect to the wrapper, like to the proc, you need to know where it is. So you need to go look for it. You need to have like a name service. You need to search. I mean, it's not something that you can easily do. So we went for looking for job queue systems, which is basically what we are focusing on here. And basically, a job queue system is composed of three main components. You have the client that wants something to be done. You have the worker that is the process that will run your task. And you have the server, which is basically the queue, the list. A job is what we want to be done. And the main possibilities with the Python, I mean, there's two main systems of Python. It's like Celery and Gearman. Celery, basically just a communication protocol with the libraries, and it's more like a communication. It uses, in the backbone, it's Redis, or I think it's a RabbitMQ, so you can choose one of them. It's independent. You basically have your API for the client and the server that will communicate through a third-party application. Gearman is the actual server. Then you have APIs that will basically be used to communicate with the server itself, and it's the server that's going to manage the priorities, the timeout, the handling of all the clients and server and workers. So how do we use this with Python? Like, I mean, very simple example. So first of all, what is exactly Gearman? So this is an image that I just took from their website. It's basically fault tolerant. So it's multi-server, meaning we have two job servers. They can be in different machines. If one goes down, it's either because the server went down or because network went down. The other one continues. You have multiple workers. They can be connected to one server, or they can be connected to multiple servers. So if they are in a different machine and the server goes down, they will know this, so they will keep working with the remaining server. Your clients also, they will connect to the servers. But if you put a load balancer, it's all good. So if one server goes down, you basically still have all the clients going to the remaining one, and everything keeps running. The only problem is that it's a queue system, so you will have probably jobs in a queue when the system goes down. But there are also ways of somehow to cache this, to store it, so that if once the server comes back up, your tasks will be reloaded and we can just continue. Or the simplest way is like if the client dies, sees that the server died, you'll just connect to the next one and ask again. It's distributed. There's an API for monitoring, and I'll be coming back to this at the end. And the best part of it is that it's a multiple programming languages API. So we have Python, PHP, I guess Java, C, I mean, a lot of them. And this was important for us because all the NLP infrastructure, it's done on Python, but everything else is not. Like, they all basically run in Java, PHP, some small C stuff, so everything else is in any other language, and what we wanted to do is like, okay, the process is in place. We cannot just go and plug something in the middle. That will not work well. We need to have something here serving, and the existing code needs to start asking this application. So we need to start having like, okay, we now are going to offer like a sentiment analysis. We want to add this to the system. We cannot just put something in the middle that will disturb the whole crawling system. We need to have it outside. So going to a very simple example, like I'm going to work like just explain like how would we do for language classification. So we were having like a client which requires like the worker to do language ID. And we'll see also how do we monitor and what you can do with monitorization. So starting with the communication part, this is how it's handled by the server. So the first thing you can do is like you can want to create like the worker and the client, and you call it very simple. I don't know if you guys can actually look, it's quite small. I don't know if it's visible to everybody, but sorry for that. So the first thing you do is like you create a worker and a client, if you like, from each side. But how do they communicate? So the data communication process is in binary. Everything that goes through the server is binary from the server point of view. I mean, you can basically throw anything you want. So if you can throw anything you want, why not JSON? So it's simpler. You don't need to be converting stuff. You don't need to create weird protocols. You just convert it. And you can do it simply. You extend the class data encoder. You define the method to encode. You define the method to decode. And you have something that will basically do JSON. And how do you use this? You create your own worker class. You say that the data encoder system is my new class, and you just create a new worker. And now what you have is that your worker will not receive binary data, but you'll receive already JSON decoded data, because when it gets here, we have the string, so like we have our text, and we just return it into an object, a simple object, of course, it means JSON. So usually dictionary, that's usually the best way to go around. So you send your parameters in the dictionary. Of course, I mean, if it can be whatever, and if everybody's working with Python, just pickle. It's the simplest way, and now you can basically send a Python object around. So you have your client, he wants to process stuff, he sends a Python object, and you don't even care of doing all the pickling and unpickling because it will be done through the API. So the worker. So we start by defining what the worker needs to do. In our case, we want to do language classification. So what we are going to do here, we create our language ID classifier object, which is basically, I mean, just like it's a model to identify. And we are going to identify the methods, in this case more like the functions, like what is actually done. So we receive the data, we get our object. So here is through a dictionary, since we have like through other languages, we do JSON for communication. So we grab from a dictionary our data in the dictionary, we get the text, we classify it, and we send back a new dictionary with the probability of being a specific language and the language that was found. We can also have multiple. In the same worker can actually have multiple services. So for example, let's say I want to do the same, but I don't need the text. You just give me the ID of the document, and I will myself look into the database, I will collect the text, and I will do everything else the same, and I'll send you the results. So this can be in the case, for example, I mean, in the interface, when they're processing stuff, they want me to show the data. They don't really care about collecting the data themselves. They want to say, this is the data you are going to collect, go check on the database what it is, process it, and give me the results. So we can actually have multiple services in the same worker. Of course, it will be running one at a time. It won't be like multi-process or whatever. So each worker will run one or the other. And then we can actually create the worker. So again, I just use the same class, I set the name, I set the tasks, and I put it into an infinite loop running. Now I have my worker, or I have 2 or 3, meaning the same code, you can launch it as many times as you want, and if you need 20 workers, you grab the same code, you just launch it 20 times. There will be 20 processes running in your machine, and they will be independent from each other. Just one point here, as you can see, I actually use a list. It's always a list in any case. So meaning, if there's more than one server, it will connect to all the servers, and it will be pulling the servers to know where is the data. And this is important for us because what we have is, we have at least in 2 machines, and there will be a set of workers that will be specific to a machine, so they will only be running on that machine, and there will be another set of workers that will be looking at the 2 machines, at the 2 servers, so that kind of to balance, because I mean, all data is not equal. A tweet will be much faster to process than a big blog, so we cannot really control that in load balancing. So I mean, there will be this extra service just to catch up when one is getting delayed. From the client side, so the client side is like, it's an example like running asynchronously. So the first thing you do, you just create your client. This is a different way of doing. So if you can just basically create a client with a basic class and just define the data encoder attribute to your JSON decoder, and it works anyway. So it's the same way. You don't need to actually go and create a whole new class just to define a different data encoder. And then what you want to do is that you want to send your job to get the results. So you do a submission, you tell it what's the task, you create your data. So you just put your dictionary, you tell it a priority, and you say wait until completed false, so it will just run away. I mean, it will not be waiting for the results. You can actually send multiple ones, and then you can just put them all in a list, and you just wait to see when it's completed. You just put like a simple checkout, and you can go through your list, iterate, and see which ones are complete. So if it's complete, you get the results. It will be again the result already. It's not a JSON format any longer. It's already your object. So another dictionary. Of course, in its timeout, you just do create a warning, do whatever you need to do in this case. Getting back then to the management, this is something also which is very interesting for us, which was what? Like, we have our server, but we want to know what's going on. I mean, for multiple purposes. So what you can do is that you go actually not serverless, just the server itself, you create like a gearman admin client, and you do get status, and what it will return. For each of those tasks that we've seen, so like in my worker example, I had 2 tasks, it will return us a status. It will tell me that I actually have 8 workers which are inactive, they're just chilling there. I mean, this is just bogus data. It will tell me how many actually are running, so processing data. It will tell me the task name, and it will tell me how many I have in my queue. Having running workers like 8 and data in the queue is possible, because again, remember that a worker can have multiple tasks, but it will only be performing one at a time. So if you have like, maybe they are like idle to this specific task because they are processing the other task. So this is totally possible. But what can we see from this data? We can see like what's the queue size, for example. And that's important because you can see, we can monitor it, first of all. So if you have your cacti graphs and you see that your queue is always at a huge level, it's because you probably do not have enough workers. So what you can do, I mean, one simple thing, you actually can have a monitoring tool that is always kind of probing the service. And if you see that your queue is getting too big, you can just spawn more workers, and it will eventually come down. You can preemptively do this. I mean, if you analyze your data and you know that specific times of the day things increase, like every day in the morning, people love to tweet. It's the first thing they do. Probably they're in the toilet. There you go. I get my tweets. I retweet. I do whatever. So your data will increase. You can predict this, and 2 hours before, you just launch all your workers. And when the flux of data comes, you're ready. But you can also if, for example, there was a crisis, so everybody started suddenly to talk of something when there was the airplane that crashed. I mean, everybody just started tweeted, like started to comment. It's something that happens. So what you do, like you monitor it. When things go up, you launch more workers. And this is also good because also you can see how many workers are active. And this can be, for example, to see if, for example, something crashed. I mean, if you know or you expect to have 10 workers and suddenly your status tells you that we only have like 5 workers, something went wrong. Either because like one of the servers went down, they missed the connection, or there was a bug in your code. So you can basically also monitor through this way. And this is basically it for the presentation. I don't know if you guys have any question now. Just so that if somebody is interested, we are hiring also like specifically for front and back end developers. If you are interested, you can just talk with me later on, or just simply just to go to the website, see the options and ship them, send the email. So questions, yes?
I have a question about durability of gearman and how it handles consistency.
How about?
It handles the consistency of the queue because it's distributed.
No, they are always independent. So each server queue will be independent. They don't really share among them. So what happens is that when your client, you can actually in the client can give 1 or 2 servers. The simplest way is to give 1 server that is a load balancer if you don't stay connected. So if you just something that you connect, you send a request and wait for the answer, you just put load balancer. So what will happen is basically load balancer will balance between both, and then in the worker side, if you're connected to multiple ones, they will somehow balance. So you never really have like a huge discrepancy. We never really saw a huge difference of queues. They somehow end up always balancing themselves.
Have you used this in combination with a distributed file system?
Distributed clusters?
File system.
Sorry, I could not understand.
Distributed file system.
No. So, I mean, that's something else. This is just to process. So this is like, think of this as a web service without being a web service. So it's like, it's a service, it's independent, and I don't care or know where the data is coming from, and just connect.
So you ship the data, the client ships the data together with the request.
Yes.
Is that how I should see it?
Depends. I mean, in my example for the worker, like I had one, I only received the ID. So in this case, because I mean, if the client goes to the database, collect the data, send it to me, and then just receive the results. I mean, this all back and forth of the data maybe is not very optimal, so you can just send me the ID and I will be the one collecting. But from the side, I mean, I will just use like, like a database access object or HDFS access object, and I just access it. So, I mean, I don't know if that answers your question or not.
Yeah, it does. Do you know of any people who do use a similar setup together with a distributed file system?
I tried to remember where I read something, I think it was some music distribution system, not Spotify, and they were using it, but for a logging system. So they had a worker that was a logging system, so that instead of directly sending to the HDFS file or to a database, they were sending it to a worker, so that and then it would be the worker storing all the log messages.
Okay, so where I'm trying to get at is, can the gearman system do something with data locality?
With?
With data locality.
I see, like an Hadoop system that basically knows where the data is. No, himself, no. I mean, if you want to do that, in this case, for example, what they had is like, okay, the worker can be anywhere. So if you're going to have a worker that logs data, you're going to put maybe this worker on the logging data database. So this is the system that's going to store the data. So you put the worker where it's being stored, so that all the data goes there.
But then the client would have to know that.
The client doesn't care. The client sends it to the worker, and I mean, but if you're logging, everybody's sending log files from everywhere. And then it centralizes. But if you want to do just, I mean, this is not an Hadoop system. So basically, the data needs to come from somewhere. So it's not, if you want to do, for example, for us, what a Hadoop system are useful for? To prepare the data. So if you have this amount of data that you want to somehow process it, treat it, and collect it so that you can create your model, there you use an Hadoop. This is once you already have the thing and it's in deployment. So for example, while we are crawling, the data is not even in a database. It's just going through our system, like our process system. So there's no place to go for that. I mean, if you want to use multiprocessing, parallel processing with care where the data is, just go directly to some kind of Hadoop system or a Spark.
Okay, thanks.
Further questions? Yes.
Have you or do you know of applications where gearman has been used in multiple OS platforms or machines which have different operating systems?
I'm sorry, I hear you very badly.
Is it possible to use gearman with a machine running Windows and another machine running Linux?
With machine learning, what?
So can you use gearman with different machines, one of which is running Windows and the one is running Linux, things like that, different operating systems?
Yes, you can.
Okay.
So each worker basically has, for us, we have, so I don't know if everybody understood, if you can have in different machines, different services. So each worker, I mean, for each service, be it language classification, topic classification, automatic sentiment analysis, we have, for each service, we have a different worker, like a specific worker. And then you can decide by yourself if you're going to use a different server per service. We decided to put everything in the same. So we have, the server is the same, but they will be connected multiple different tasks. So each task will have its own queue.
TCP/IP port on which each of these servers and clients connect.
Yeah, I mean, you basically have your service, because that's the thing, the actual work is being done on the workers. So the queue system, the server where the client connects, is just kind of a way of this, sending data to wherever it needs to be processed.
How would you compare gearman to another message queuing system such as 0MQ?
Sorry, with the echo, it makes it worse.
So how do you compare gearman to a message processing system?
Like a message like Storm? Or?
Like 0MQ, for example.
That's what, for example, it's very similar. That's, like Celery. So when I mentioned how it works, Celery is basically that. Celery uses RabbitMQ or Redis in the backbone, and it's only actually the communication protocol. So it's just you have a client that will send the data to a message parsing system, and you have a worker. So it's exactly the same. So the difference being that gearman does not require more Redis on the side. It does everything by itself. Redis itself is built in C. But the principle is the same.
Further questions? Not the case. Okay. Thanks again, Pedro.